Okay, so hello everyone, this is Akshay here, and let us continue with today's problem of the day. Today's question name is binary, bottom view of the binary tree. It's a very standard question asked in many good companies, Medium, Flipkart, Amazon, and stuff. So by the end of this video, you'll be comfortable in solving this question. So we're gonna see complete the video in three steps. First, understanding the question, the dry run of the first input case, and the live coding of with Java, and then a reference for C++. Before starting ahead, this is my DSR repository. You can see that's the yesterday's problem which we solved yesterday, and that's the whole repository here. You can start and fork this repository to get help with your interview preparation because it consists of actually 500 plus submissions of the standard question. It will be very handy for you. And jumping back to our channel, which is nothing but code and record. And here's a walkthrough. And to understand the complete topics of a binary tree, you can go to the DSA A to Z topic wise, and you will see there's a bunch of playlists here. Among them, you can find the binary tree playlist. You can click on that, and then you'll have 36 standard videos or 36 standard question in which you'll have a very clear understanding of how BFS, DFS, from post tree to in order and post order, what are they and how to convert between them, balance tree, duplicate elements, binary to CDLL, that means cyclic doubly linked list, right? So that's it. And let us jump back to the question now, and we let's solve it. So if you're new to this channel, do like, share, and subscribe. We're getting help with the video. And let's get started. So we've been given a root of a binary tree. We need to print the bottom view of the tree. So what is actually a bottom view? So let us draw the tree in a clear format so that you can understand the views. So this is 2 and 5. So if you draw the 5, the node which consists of 5 value, it will just come below this one, right? Similarly, we'll have this 3 and we'll have this 6, right? Now, how do we define that? What are the bottommost nodes? So we just, for reference, we drew this vertical line and let's say mark this as index 0 and vertical line mark this as index 1 and again a vertical line mark this as index 2, again a vertical line. Since we're going back from 0 to it would be -1 and let's say this has -2, right? So for each vertical line, what is the first node which we can see from this angle, right? The first is this is 4, right? This is 4. This value, this value, this value, this, and this, right? And we need to print from left to right. So basically, this is the order 4, 2, 5, 3, 6, and that is the given expected output, right? How do we solve this question? So we will do a generic BFS in this one, and we will push the values into our map, right? With these vertical values, right? And since we want the values coming from left to right, so we will use a tree map here that will help us to give the values in a sorted format, and we'll use this keys. You'll use these indexes, or let's say the -2, -1, and 0 values as the keys of that tree map, right? Let us do a very quick diagram, and then we can move ahead. So this is our queue. First, we'll push our queue node, and queue node, the first root node, and we will be pushing actually the node and this index value, right? So we're gonna need a custom data structure, let's say pair, which will have two things, a node and a width, right? So this 0 is nothing but you can say that's a width actually, right? If you just sum it up 1, 2, 3, 4, 5, so the width of the tree would be 5. So any variable is fine, width, second, x, y, whatever you say. So let me take this as the second variable as width, and we're gonna push the root node 1 and the index value, right? Or let's say the vertical index value. So 1 comma 0, right? And we will then push this in our tree map. So tree map will have the values at this index value with the root node data, right? And we're going to push the process the left children of this, the node which you just pull out. So this would be nothing but 2, right? So the node value with the index value. So this is the left node, and then there goes the right node, which is nothing but 3 comma plus 1, right? Now we process the second node, which is 2 comma -1, and we will push it in our map. So it will be nothing but -1 comma 2, right? And we will be processing its children, that is 4 and 5. So we'll be pushing 4 comma. So this is -1, right? So since we are taking the left child, so we'll do a -1 in this particular value, which will be nothing but 4 comma -2, and we'll be pushing another the right children of this 2, which would be nothing but 5 comma 0, right? Since we are going right, then we'll take the current index value, vertical index value, and we'll do a +1. So -1 plus 1 will be 0. Now, going on to the next node, which is 3 comma -1. So again, storing the index value first and then the node value, right? So this is nothing but the index, and the second thing, the value of this tree map is nothing but the node value. So node val. So 5 comma 0 has been pushed, and now we'll be processing the next node in the queue, which is 4 comma minus 2. So there is no children to process, so we'll just directly push it in a map. So this is minus 2 comma 4. Now the next is hmm, what's say? So 3 comma minus 1 we process, right? So when we process this 3 comma 1, there was one children of it, that is 6, right? So we're gonna push that value, and I think that will be pushed here itself. So these two nodes were the children of, okay, yeah. This node would be coming here. There is nothing but 6 comma 2, right? Yeah. Let's proceed on. So 4 comma minus 2, no children to process. So we'll just directly in the map. 5 comma 0, no children to process. We will directly push it in the map. But we wanted the bottommost uh, we wanted the bottommost view of the tree, right? So in this particular, let's say in this one, 0, right? So 5 is the answer. So we will search for that particular key. If that vertical index is present, we will update this value with our new current value. So it would be nothing but 0 comma 5. Again, there are no children to process. We'll move ahead in the next element in the key, which is 6 comma 2. And again, there is a no child to process with 6 comma 2. We'll be directly pushing into our map. So 2 comma 6, right? Since it's a tree map, it would be sorted. It would be sorted in the ascending order according to the keys which we have given. So this would be nothing but minus 2, minus 1, 0, 1, and 2. And the corresponding values would be minus 2 corresponds to 4, minus 1 corresponds to 2, and 0 corresponds to 5, 1 corresponds to 3, and 2 corresponds to 6. So 4, 2, 5, 3, 6. This was our actual expected output, right? So 42536. So we are good to go. Please pause this video here and try to code this approach by yourself, and we'll see a live code in Java. Now, before moving ahead, what is the time and space? So time would be, since we are doing a standard BFS, so the time for BFS is O of n, because we are visiting each and every node, and O of n as space as well, because we are using a queue, right? So this would be time, this would be space plus O of n, which we are using for map, right? Or let's say O of width, we can say we are using for map. But considering the higher complexities, it would be O of n plus width. Considering it higher, it would be O of n as space and O of n as time, right? Now, I hope you were able to code this approach. If not, let's get started with the live code now. Okay, so first come first, we will make a custom data section, let's say pair, and we'll have two values there, or two properties there, the node and the width. So let me write that, do the constructor initialization, and let us resume back. So that's the step one. And step two would be that we will be starting this function. So let's say the return type is arraylist of integer. So we're going to say arraylist integer. We're going to name it AL. And we're going to say new array list, right? Now, base case come here if root is equals to null. So therefore, there is no root present in tree. Then in that case, we'll just return an empty array list, right? Step two would be taking a temporary node, which will be storing the head of our queue, right? So let's say node. Node temp is equals to null, and then we're gonna make a queue where the type would be our custom data structure, that is pair and queue, and complete the initialization of this. So new linked list, right? And now we're gonna have a map of integer comma integer. So declare a map and add the first node in the queue. So let me do that. Simultaneously, I'm writing some comments for you guys to understand. So this queue is for BFS, or let's say the level order traversal, which we have in our tree. If you're not aware of those things, then do watch out this playlist and you'll get to know about ins and out of our binary tree. And again, if you're new to this channel, please like, share, and subscribe, and let us proceed ahead. So doing a standard BFS, so we'll be pulling out queue until all the elements are processed, right? So we'll be saying while queue dot size is greater than 0, right? So step one is to store the node, store the top node, pull it out. Second step would be pull it, and third step would be process its children, right? And then add in map. So try to code all these four steps, and then you can move ahead. Now we are gonna add this particular port node into our map. So map is nothing but empty mp dot put this particular index, the vertical index, which corresponds to D, and the node data. So it's nothing but temp dot data, right? And then we'll be processing its left and right children, right? So let me write for once one if for the left, and then you can write it for the rest of it. So if left dot temp dot left not equals to null, then q dot add Now we're gonna take the same index, right? And we'll be saying new pair, and we'll be taking the same index minus one because we are processing the left child. So temp dot left comma d minus one. Similarly, we have to write for the right child. The only difference would be d plus one for that, right? That would be it. And at last, whatever values which we have in this tree map, that is, we can just say in data into mp dot. We need to traverse in the value set, right? So we'll just say values, and we can add it in our array list. So al dot add data, and at last we'll just say return al, right? Let us compile this code, and then we can proceed ahead with the C++ reference. So that's great. The expected output has been matched with our output. Let us submit this solution, and then we move ahead with the C++, and then we can end this video. Great, yeah, the submission, it has been successfully submitted. Now let us switch back to our C++ reference. So again, we will cover this code walkthrough in 4 steps. So first step, we made a custom data structure pair which has the properties node and width, or let's say the vertical indexes or whatever the variable name which you want to say. And then in this particular function, so four things are there. Again, three things are there. The base case, if the tree is empty, then definitely we return an empty array list. We have a queue, we have a map, and then we just did uh, in the queue we pushed it, and this is the basic BFS traversal which we did in Java for the level order traversal, and at last we just map all the values from the map back to an array list, which is vector in this case, and we return that vector. So that is it. Let us hit the submit button for this code as well. Great, the code has been successfully submitted. So many of you have been asking me to provide the C++ reference, and that is why I'm doing so. So if you have any further more requests, any doubts, or any suggestions, any more approaches, do comment in our comment box. And let us meet again in the next video. Till then, keep learning, keep going. Bye bye, and take care, guys. Do not forget to like, share, and subscribe. We are taking help from this video. I'm targeting 10K by end of this year, so support me in that, and we'll be doing wonders in the coming time. And let's keep cracking the product-based companies. Till then, bye bye.